4.4 factoring. There are different ways of factoring, and this video is going to highlight some of the different ways of factoring polynomials completely. Just a reminder, if you have problems like this, the first approach that you would take is to factor out the common factor of each of the terms. X is the common factor, so I would factor out an X of each of them, and then I would go ahead and try to factor the remaining one, the remaining trinomial, and this would be minus 5 plus 1. Again, negative 5x plus 1x is a negative 4x. Similarly, I would look and see 3y cubed is the greatest common factor between the two. That just leaves you with y squared here and 16. That's it. So now you have this, and these are perfect squares, difference of perfect squares, y and y plus 4 and minus 4. Again, middle term, 4y minus 4y gives you 0y, which is non-existent, or 0y, which is 0, and that means that there's no middle term there. And so we'll do one more. 5 comes out, and it's 5z squared. Z squared, let's see, plus 6z and plus 9. And so if you factor that completely, you're going to see that it's x plus 3 times x plus 3, or x plus 3 squared. Now, there are different ways that you can factor when you have the sum or difference of cubes. And this is a pattern. So what I like to remember is the sum is where it's the same, a plus b from a cubed plus b cubed, and the difference is where you're subtracting. Or if you get this one down, you put in a negative b, and you would see that you get what's beneath it. Negative b squared is b squared, right? So, so you really only need the one, and then just substitute in a negative to get the other one. Or you can remember that these signs are opposites. And you're starting with the same sign as what you begin with. Now notice when you're factoring something like this, first break it down to determine what your a and your b are, and then you can substitute in your a and b as they did in the examples. Looking at this, if I wanted to, I could say, oh, okay, well, this is x cubed minus 5 cubed, and now I can say, well, that factors down to x minus 5 times x squared plus 5x plus 25. And this would have common factors, so you would factor that out. Go ahead and looking at these, remember that you can factor by grouping. They sneak this in here, but you have 4 terms here. And I'm looking at the coefficients. 1 over 5 is the same thing as negative 4 over negative 20, which tells me that I can group this. So z squared comes out on the first 2 terms, z plus 5, and negative 4 comes out, z plus 5. And so this becomes z squared minus 4 of these z plus 5s. So it really looks like that, z squared minus 4 of these x plus 5s. And you can factor one more step because this is a difference of squares. Always looking to see if there's more that you can factor at the end. And at the end here, I'm just going to say that x is equal to z. Got a little carried away with those z's. I don't like making them anyway, as you can see how sloppy they are. Going further on one last type of factoring, if you have something like this, notice that these are perfect squares. So what I like to do is just put this down and say this has to be the square root of the first term, and this is the same thing, and this has to be the square root of the last term. And so when you do this, you get 36x squared, and negative 36x squared doesn't give you a middle term. But then you have to do it one step further on the next one because it's a difference of squares. And so this is just going to be 2x plus 3 and 2x minus 3. I did this pretty quickly. As a review, the main focus is going to be on the patterns. Now, the other part of this is tell if a certain binomial is a factor of a polynomial. If it is a factor, it means the remainder has to be equal to 0. Remainder is equal to 0. So what I like to do is just plug in the k and determine if it's 0 or not. If I'm looking at a, remember, that's the factor. My k is really equal to 2. So f of 2 is equal to 2 squared plus 2 times 2 minus 4. And let's see, it's 4 plus 4 minus 4. So this is not a factor. What is not a factor? X minus 2 is not a factor. If this was 0, then it would be a factor. If you don't like doing this type of substitution, what you can always do is the synthetic division, and that right there, when you get to the end, would be the remainder. If it's 0, then the binomial is a factor. If it's not 0, which is the remainder, then it would, if it is 0, it is a factor. If it's not 0, then it is not a factor.